Okay, looking at the period of a graph, graphs are periodic if they repeat the pattern over and over. So these four graphs are examples of periodic functions, and if you're looking for the period, you're looking for when it starts to repeat itself. So this one, if you just kind of follow along, and you just got to recognize the pattern. So right there is the start and end of its cycle, because your first move is to go up all the way to 1 and then down back all the way to -2 and then a little W. So that's one period, and then it starts over. So up, down, up. So from start to stop, before it starts to repeat itself, that is one period. So this period, this graph right here has a period of 4. This one over here, so first we go horizontal one, then down a couple, then horizontal one, then up, and that's one period. Because then it just is going to repeat itself over and over. Horizontal one, down a couple, horizontal one, up, and over. So this period, how far does it go before it starts repeating itself? This starts right here and it ends right here, so this one has a period of 2. Okay, the bottom left one, it goes over horizontal, then up, then over, then down, then over, then up, and that is one cycle, start to stop, which is, it's going to do that in 2 pi, or 360 degrees. Okay, now this last one starts and then it kind of curves up, and then kind of curves down, and that is it right there. Stop, and that again is 2 pi. Okay, now this is a periodic function, and now we're gonna determine a few things. So the period, which is kind of what we just did, let's start it right here. Now this is kind of a maximum, so you're gonna go down, turn around, head back up, and then right there to the maximum again. Then it's just going to repeat itself. So this one cycles through, takes 5 units. So the period is going to be 5. The maximum and the minimum. The maximum happens if that's 1, 2, 3, 4, 5. The maximum is at 5, and the minimum is kind of the lowest point, the lowest that it goes, and it is 1, 2, 3. So the minimum is a -3. Okay, the amplitude. The amplitude is the difference between your maximum and your minimum. So from my maximum all the way down here to my minimum, how far is that? What's the difference between that? What's the distance between that? So if I do 5 subtract a -3, the distance is 8. So I'm going to go 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. So the distance between your max and your min, and then I just need to cut that in half, divided by 2. So my amplitude is 4. Okay, now the last question, the vertical shift. My vertical shift, it has been shifted up a couple. So let's see if we can figure out how many. So if my amplitude is 4, that means 4 above the middle and 4 below it. So my middle, 1, 2, 3, let's see, 1, 2, 3, 4. My middle is right here, because there are 4 units above it. 1, 2, 3, 4. That's to the top. And there's 4 units below it to get to the bottom. 1, 2, 3, 4. So this is the dead center. But the dead center needs to be anchored on 0. So this center has been from this line of 0, this whole line is 0, this has been shifted up 1. So my vertical shift is 1 unit up. So to find the vertical shift, you got to find the dead center. If the dead center is not on 0, that means it's been moved up or down. Okay, now we're going to graph them. So let's graph the parent function. The parent function is just y equals cosine of x. So hopefully you got this in your notes. Starts off at 1, and it goes down to 0 at 90, and then a negative 1 at 180, then back to 0 at 270, then back to 1 at 360. So it starts, that is one period, and then it's going to go back down to 0, down to negative 1, then it's going to kind of repeat itself because it's a periodic function. Okay, so that's the parent. Now we're going to transform it. So I'm going to change colors and probably do the transformation in a pencil, because we're going to have to probably draw a few dots and erase them. So first of all, maybe I'll start with the amplitude. So your parent function, the model for this transformation is y equals a times the sine of b times x minus h plus k. So there's 4 things we can do to it. K, if you add or subtract at the very end outside of all the parentheses, that's going to translate it vertically, so that's going to move it up and down. If you add or subtract in the parentheses this h, that's going to move it to the left or to the right. Remember, this minus is part of the model, it's not part of the number. And then if you multiply right here, that's going to change your period, and that one's a little tricky to find. And this one's just as easy as the h and the k. This one, this a, if you multiply at the very beginning, that's your amplitude, and that is how that's your max and your min. So this right here, that's my amplitude. So instead of going up to 1, this is going to go up to 2, and this is going to go down to a negative 2. So this dot's going to go up to 2, and this dot's going to go down to negative 2. So that's my amplitude. Everything else stays the same. It's just going to change my max and my min. Okay, this one is going to change my period, and your period, it cycles through on a trig function. It takes 360 degrees before it starts repeating itself. So my standard period is just 360 degrees, or 2 pi radians. Okay, now how to find your period, your new one, is you need to take b, and you take 2 pi and you divide it by b. Or you take 360 and you divide it by b. So since we're already in pi's, I'm just going to take 2 pi. So I'm going to take 2 pi and I'm going to divide it by 2, because that's what b is. And now my new period is going to be pi. So what that means is now I'm going to start at 0, but I'm going to end at pi. Instead of ending at 360, I'm going to end at pi. So what that's do is it's going to compress this graph horizontally. It's going to kind of squish it like an accordion. So this is my ending dot right here, which got moved up because I've got a higher amplitude. So this ending dot now needs to scoot over to pi. So I'm going to end right here. This is my new ending. So I can erase, let me erase this one. Let me erase this one. And this one right here also needs to be compressed horizontally. I need to scoot it over, and it's going to go to right here. Okay, so if I were to draw it, it would look like this. But I still need to do one more thing. I've got that done, I've got that done. Now this, I need to shift it horizontally. My phase shift, that's called a phase shift. So I need to shift it pi over 2, which is 90 degrees. So I need to move every dot 90 degrees to the right. So I'm going to move this dot to right here. I'm going to move this dot to right here, and I'm going to move this dot to right here. Okay, now I'm going to erase those other dots. And there we go. That's one period, and if we were to just repeat and do it over, I'd have a die here, die here, die here, die here, and it would just keep going down and up and down and up and down over and over. Okay, so let's find the amplitude, the period, the phase shift, and the vertical shift of each of the following. So y equals a times the sine of b parentheses x minus h plus k. Now, it is very important that the coefficient of x is a 1. So this first one is okay. This first one's not too bad. But that whole thing divided by 2, that is the exact same thing as 1/2 times the sine of 3x. So this is equal to, so timesing the whole thing by a half or dividing by 2, it's the same thing. But if I look at it in this perspective, it's going to be quite a bit easier. So my amplitude is going to be 1/2. So my max is just going to go up to 1/2. And this 3 is b. That's going to change my period. So my period is 360 or 2 pi. I'm going to take 2 pi and I'm going to divide it by 3. So my new period equals 2 pi divided by 3. Okay, the phase shift, that's the h, that's what you add or subtract in the parentheses. And there's nothing I'm adding or subtracting in the parentheses, so my phase shift is 0. And the vertical shift is the k, it's what you add or subtract at the end. There's not a vertical shift, so that is also 0. Okay, now the next one is tricky. So my next one is not quite ready to look at because my number in front of x is not 1. So this number right here, I need to factor out. So I need to divide both of these by 2. So I need to rewrite it and look at it as y equals 4 times the cosine. If I divide both these by 2 of 2 parentheses x plus pi divided by 2 minus 4. Okay, so if I distribute the 2, 2 times x is 2x, and 2 times pi divided by 2 times by 2 and divide by 2, that's going to cancel out and leaves me with just pi. So my amplitude is equal to 4. My period is equal to 2 pi divided by b, and this is b, so 2 pi divided by 2. So my period now is just pi, or 180 degrees. My phase shift, okay, this is kind of tricky. My phase shift is pi over 2, but I'm actually moving to the left because there needs to be a minus in the model. And I've got a plus, so I've actually got a minus, a negative. Because a minus and negative is a plus, so that means this is actually a negative pi over 2. And then my vertical shift, that's what you add or subtract at the very end, my vertical shift is a negative 4. So that is all of the transformations that graph made. This last one is kind of the same. We've got to get 1 in front of the x, and right now I don't have a 1, I've got a 3, so I need to factor out a 3. So let's divide both of these by 3, and let's rewrite this as y equals a negative sine of 3 times x minus 2 pi plus 1. So now my amplitude is equal to a, and there's really not one. The negative, what the negative does is it takes your graph and it flips it upside down. So it would look like this. but the amplitude is still going to be 1. So the amplitude is 1. My period is going to be 2 pi divided by b. That's what this is. So 2 pi divided by 3. So my period is kind of the same as this first one, I guess. 2 pi divided by 3. My phase shift is h. That's what you add or subtract in the parentheses. So this minus is part of the model. It's not part of the number. So my phase shift is 2 pi. And my vertical shift is 1. Okay, so consider the functions sine of x. That's just the parent function. So sine of x starts at 0, goes up to 1, back to 0, down here. It just keeps doing that over and over. So this is the parent function. Okay, now this is a transformed function. So let's see if we can figure out what's going on. Okay, that's my amplitude. So I'm going up to 2 instead of my maxing out at 1. I'm going to max out at 2. There's no period change. My period's still going to cycle through at 360. And then this plus pi is actually minus a negative pi. So let's see if we can start making some changes. I'm going to max out at 2 and I'm going to min out at negative 2. So that takes care of that. I'm going to shift every dot to the left 180 degrees. So this dot is going to go over here to right here, because 2 ticks is 180. 2 ticks is a pi. So I'm going to take this one over 2 ticks to right there. And I'm going to take this dot over 2 ticks to right there. So let me erase those old ones. Then I gotta do this vertical shift, this -1. So now the -1, I'm gonna take every dot down 1, down 1, down 1, and then let me erase those old dots. Okay, and I'm just gonna connect them, and maybe I'll put some more dots in. So I'm gonna go over 2 more, put that one there. Over 2 more. Okay, so it's going to look like this. Alright, so look at the purple one. So the vertical stretch is different than the vertical shift. The vertical shift, we moved this a -1, so the vertical shift is down 1. The vertical stretch, that's your amplitude. So my amplitude, it was stretched by 2. So it's maxing out at 2, and it was mining out at a -2, but then we shifted it down 1. So it was stretched by a factor of 2. Determine the domain and the range of the purple. Okay, the domain is the x-axis, so left and right. And this, since it just repeats itself, it's going to go on forever. So the domain is -infinity all the way to +infinity. The range, though, is the y-axis. That's up and down. My max is 1 and my min is a -3. So my range, anywhere from a -3 to, I guess, +1, including, so they got to be the brackets. So anything in between here, -3 to 1, that's my range. Okay, the phase shift, that's the horizontal shift, that's left and right, and we moved everything left 180 degrees. We moved everything left 1 pi radian. Okay, now you're given a graph. Can you look at the graph and figure out what the transformed function is? So the parent function is y = sine of x. So let's see if we can figure out, let's look at the max and the min. The max and the min, I go all the way from 6 down to a -2. So from here to here is 8 units. So 8 units, halfway between that is 4. So 1, 2, 3, let's see, where is it? Right here. That's got to be the halfway, 4 above and 4 below. So my amplitude is 4. And this is my dead center, and it should be down here on 0, so I know that it's been shifted up twice. So my vertical shift equals up 2. Sine, on the test I will give you a phase shift. I will not give you a phase shift because that gets too hard, that gets kind of tricky. So all you need to check is the amplitude, the vertical shift, the phase shift. There will not be one, but you can figure out the period. Okay, the period, it needs to start at 0, and it needs to go through its cycle, and it needs to end its cycle. That is one cycle right there, because then it starts to gain again. It needs to end its cycle at 2 pi, which this one does. So this one did not change the period at all, because it needs to cycle through at 360. So all I need to do is put an amplitude of 4. So y equals 4 times the sine of x, and then at the very end, let's do a vertical shift of +2. And that is the function that gives this graph. Okay, let's look at this one. Now these are all from the parent function of sine. So sine starts as 0, goes up to 1, comes back down to 0, goes to -1. That is the sine. So this one looks like it's been shifted up, but it's been flipped upside down, because it should start at 0 and it should go up and then down. So this one has been flipped, so it's going to be y equals the negative. Okay, now there's my halfway, and my maximum is up here at 3, and my min is at a -1. So my amplitude is just 1. And I don't even need to write that. So it's -1 times the sine. So let's see if the period has changed. My period needs to start at 0, and it needs to end at 360. And there's the ending right there. So the period has changed. It's been compressed horizontally, so it's been pushed together. So actually, there are 2 of these cycles. So if I go down, up, down, right there, there's 2 cycles in 360. And that is going to be my B. My B is actually a 2. Because my period is 180. I start and finish in 180 degrees. So you take your 360 and you divide it by 2, and that is 180. So this must be what the B is. So if my B is 2, now I'm not going to give you any phase shift, so it's just going to be parentheses x, the vertical shift. So my starting dot was right here, and it has been shifted up 2. So that is the function that gives you this graph right here. Okay, this last one, okay, here's 2 pi, and here's what my parent function looks like. It starts at 0, goes up to 1, back to 0, -1, and back here. So my parent function looks like that. So this one, they have changed the amplitude. So instead of going up to 1, the max is 2. That's going down to -2. So my center is on 0, so it has not been shifted up or down. So the vertical shift is 0. But the amplitude is 2, so it's going to be y equals 2 times the sign, and it goes up, so it's positive. They didn't flip it. But what they've done is they have stretched it out. So they took this dot, the ending dot, and they stretched it out clear over to here. So now it's starting and going through one period, and it's taken 4 pi, which is 720. So my 360, I'm dividing it by 1/2. That's how I get 720. Because dividing by 1/2 is the same thing as 360 times by 2, and that is 720. So my b is 1/2 x. So when your b is a fraction, the graph gets stretched out horizontally, but when b is a whole number, like 2, it gets compressed and it cycles through faster. Okay, the last one, number 8. Let's graph the sine of x in one color. So sine starts at 0, goes up to 1, 0, -1, 0. So that's 1 period. Okay, I'm going to change colors, and probably in a pencil, because we're going to have to put a bunch of dots down and then maybe erase them and shift them around. And move them over, because this one looks pretty tough. So a negative, that's going to flip everything upside down. 3 is my amplitude. So instead of coming up here to 3, it's going to be flipped. So it's going to be down here at -3. And this one is going to be up here at +3. Okay, so my amplitude and the flipping is done. Okay, the 1/2, we just saw that. It's going to stretch it out. So my starting dot is going to be at 0, but my ending dot is going to be at 4 pi. Okay, now what's cool about sine is your starting dot is at 0, your ending dot is at 0, but your middle dot is also at 0. So this is going to be my middle dot right here. So that means if this is the middle, this guy needs to be moved over to right here. It's got to be halfway between these two dots. And this dot just needs to move over 1, because he's got to be halfway between those two. Okay, now let me erase those old dots. Okay, now that is taken care of. Okay, now my phase shift. I'm adding in the parentheses, so it's going to slide all these dots left to right, and it is minus a -pi/2. So it is going to slide every dot left 90 degrees, or pi/2. So that's just 1 unit on this graph. So this dot needs to go left to here. This dot needs to go back where it was. This dot needs to go left to here. This dot needs to go left to here. This dot goes left to here. So let me erase all those other dots. Okay, that's done. And then the last thing, I've got a vertical translation of +1. So now I'm going to move every dot up 1. So this dot comes up to here, this dot comes up to here, this dot comes up to here, this dot comes up to here. Alright. So my original function, the parent function, I've kind of erased. The parent function is going to be right here. Then it's just going to keep going up to 1 to 0 to, whoa, that looks pretty bad. So 0, 1, 0, -1, 0. So it's just going to keep going up, and down, and up. Okay, now I got to connect all these red dots. So I'm going to start here, go down, up, down, and there we go. Okay, that's it.